Yeah. Good morning, everyone. Nice to have a cheer squad for Thomas. A couple of quick housekeeping announcements. Can everyone hear me? Good. The Hacking the iPhone session at 7 p.m. in this hall is cancelled. And other than that, can I ask you all to put your mobile cell phones on silent for Thomas's talk, please? Also, there's an opportunity to give feedback on the talk. If you go to the schedule online and click on the talk, there's the chance to give feedback, and Thomas would like that, if you don't mind. Okay, let's see what other housekeeping stuff I have to do. Right, now to the introduction. Speaking this morning will be Thomas Ryback. He teaches programming in the computer science department at the Białystok Technical University in Poland, which is near the border of Lithuania and Russia, in case you're interested. He's going to be talking about Sputnik, which is the RFID tracking system that was used during the CCC Congress in Berlin in 2007 and 2008. The system tracked movement of participants at the Congress over 3 days in both years. The participants wore the tags voluntarily, but there was no collection or no reliable collection of names or identities linking to the RFID data. Thomas is currently researching his PhD in analyzing behavior of computer programs, and this work sort of dovetails nicely with that. Particularly, he's analyzing characteristics of computer programs to make them run differently and potentially more efficiently. The presentation that he'll be giving is an analysis of that RFID data, of the Sputnik data, and he's going to be answering the questions of what can we see from the data, what is the behavior of the attendees. Some of you may have been there, so it'll be a little bit of navel gazing. And also, perhaps, is it possible to guess the identity of an attendee based on the patterns that have come from the data? So if you could please give a warm wake-up morning round of applause to Tamas.
Hello, everyone. At first, question. How many people know what the Sputnik is and how it operates? About half. Okay, so I will give the short introduction to the Sputnik. Then I will return to the first data set that was made available, problems with that. Then describe the later data sets. Then show some simple analysis that I did. Tell very briefly about positions of tags. Then call about entropy and the future ideas of how this Sputnik system can be extended and how it was extended. Basically, I will not talk longly about the Sputnik system because it was described during the many presentations during 23C3 in 2006, during the camp in Germany 2 years ago, during the 24th Congress, and during the last Congress also more into analysis of social ideas. Basically, the Sputnik system consisted of the tags which were worn by attendees. Everyone was able to buy such a tag and wear it or decide not to wear it during the conference. These tags were active tags, which means they differ somehow from the ordinary RFID, which is passive and needs reader to operate. Those have batteries in them, which means that they were sending signals whether there was something to receive it or not. Hence the name Sputnik, because Sputnik was the first artificial satellite of Earth, and it was also continuously sending the radio signals. On the entire in the entire building, there were readers deployed. Depending on the conference, there were from 20 to almost 40 readers deployed, and they were able to detect presence of tags. Entire details, technical details are and design of the tags and software is open source, and it can be downloaded from the wiki. So you can download schematics, firmware used in tags and readers, and so on, if you are interested. There were 4 main data sources from the Sputnik. Chronologically, this was the first data set. It had a very big problem, which IDs of tags were missing, because each tag is sending has its own ID, which is number, and it is sending so reader can tell how which tag was active in that room at that time. This data set had missing those IDs, so it is almost useless for analysis, at least for analyzing of movement of individuals. I was trying to recover from this situation and tell it about it later. From 24C3, there was textual files. There was no problems with that data set. It was very good data set, although not very. After the failure at the previous Congress, not very many participants decided to wear the tags. Then during the last hope, the tags were incorporated into badges for the conference, so about 1,200 people were wearing tags. It is the very large data set, and it was also released in the same format as during the previous Congress. And during the last Congress, data set was also released, but it was released in a not as useful format because it was released as data dump of from the network. So it was just a result of TCP dump running for entire Congress. Here are some web pages from the system. Main pages is openbcode.org. There is wiki there, and there are also addresses of the links for downloading datasets. There was some few pages with analysis data. Leica's Dream is project for visualizing positions of tags. It was used to during the Congress to visualize movement of all the participants that took part in the project. AMD, I will talk about it later. It was active during the last hope, and Social Patterns is quite a new website. It is using the Sputnik system for analyzing social contacts, which means who is talking to whom and for how long. So this required slightly altering tags. So it was not active during the all congresses, but only during the last one. Few disclaimers: I'm not sociologist, so I'm from computer science department. So what I will be telling about this analysis is not pure science. So do not refer me for some scientific citations. The second disclaimer, I will talk about only about few examples, not all of them, and not all possible analysis methods of analyzing. So if you are interested, please talk to me later. And the second, thanks for all participants. I hope there are at least few there who were wearing these tags and were part of the project. Let's return with the first data set. It was during this Congress Sputnik was introduced, and data set had random numbers instead of IDs of tags. It was just problem with memory corruption, so not very good. I was trying to recover this by using internal characteristic of how tags are working, and I was not very successful in that. If you are more interested, talk to me later or go to my presentation from 24C3. This is how tag sends the packets. In each packet, it sends ID of tag, and it also sends a value of ever-increasing counter. The counter increases once per every packet sent. So it should mean that packet is that each tag is this is a linear function that can be counted, that can be plotted time versus value of this counter, because tag sends packets regularly. Unfortunately, for many tags, this is how it looked like. I'm afraid that some tags were broken, or maybe their owners were playing too much with them. And in this way, there is no proper linear sequence of counter values. This is another example. This is even worse, because here we have almost no linear, no straight line. And my trials of recovering of lost IDs were assuming that tags are behaving properly, which means that they are sending increasing counter values. And I'm afraid this is why I have not succeeded in recovering those IDs, because large portion of the old tags from the next conference, during which we had proper IDs, proper data set, were showing this behavior. And if we assume that the tags during the previous congress were behaving similarly, it means that that there is little chance of recovering this data set. So currently, unfortunately, I do not know how to recover this data set, and there is no much need for that, as we have more data sets from later congresses. So this first data set can be only seen as some kind of historical value for the first Sputnik project. This is also kind of strange sequence, because in the counter there should not be going back, because back in sequence values, because there is even no such code inside the firmware. I analyzed every line of it, so I have not noticed that there is some error. So I'm not sure what to think about this, whether it was some kind of spoofing of tags or replay attack or something like that. But there were only two such cases, like here. Okay, for data format, there was ordinary CSV text file with spaces between values. There was tag ID, Unix timestamp when this packet was received, ID of station that received it, strength of the signal, because tags were sending signals of varying strength to allow for better position estimation, value of counter, which was described by me just before, and flag. Flag is currently only used to detect whether user pressed the button or not. this is summary of the first useful data set. 200 tags. The difference is that tags were sending packets more than once per second. During the previous Congress, it was sending packets once every few seconds. And large increase in number of stations. When I uploaded it into my database, it was almost 2 gigabytes of data plus some indexes for faster access. So it is rather large data set. For the last hope, those are positions of readers. Here is the heaven, so this is a place for volunteers. No ordinary attendees were allowed here, so it will be important later. Here is the basement, so the lounge, hackerspace, and so on. Here is the base level. Here is cafeteria. Here was the Sputnik booth. Here are the lecture rooms. And here is the highest floor. Here is the biggest lecture room, and here were some stand-ups of Wikipedia and things like that. This is just statistical data. As you can see, there were more packets received of the strongest case. Nothing too much interesting here. There was 23, I believe, strange packets because Sputnik is operating on the range of 2.4 gigahertz, which is also used by Wi-Fi and Bluetooth. And on such a conference where there is much activity in the Wi-Fi, there are some kind of collisions. So there were 23 strange packets during this congress. Similar short description of the last hope. 12, almost 1,300 tags, 37 readers. Here it was in the hotel, Pennsylvania Hotel, so it was on the 2 distinct floors. It is the biggest data set because it has 176 millions of packets received. So this is very big data set. It is impossible to analyze it at once. And similar statistics. As you can see, nothing too much interesting. Here are packets from the last Congress, which was in the December. Unfortunately, there is no description of the readers, as you can see here. So it is not all analyses are possible because of this. So I will be just switching between the last hope and the previous Congress, not the last one. And because of new data format, I was able to also see how many tags were from the previous congresses. So there were even some tags from the first Sputnik opening. Okay, this is a very confusing picture. It basically says this is one floor, this is another floor, and this is yet another floor. Those are the stations, the readers, and lines are connecting them if those 2 stations received the same packet at the same time, which means that this packet was seen by at least 2 stations. As you can see, there is much. This is very sophisticated drawing, and also there are readers on 2 different floors that were able to read the same packet, which means that signal was able to travel through the ceiling, which makes some analysis like calculating positions more difficult because you are not quite sure on which floor the participant is. This is the same kind of drawing from the first Congress, during which Sputnik was active. So as you can see, this is much less sophisticated situation, because there was this is the smallest data set, and there were not as many stations deployed as later. For the last hope, you can see that there are two distinct floors. Here, the biggest floor, it is rather messy situation because there was no walls. At least I believe so from the descriptions. There was no ordinary walls, only some kind of very thin walls, so packets could travel through them, and many packets were read by many different stations. And for the last Congress, there is no distinctions for the floors because I do not have the data. Some statistics. During the day, much activity. During the night, less activity. Ouch. There is, oh yeah. This is comparison of the first Congress activity and the second. As you can see, similar behavior, but slightly more tags during the day, because they were sending packets much more often. So we were receiving larger quantities of the packets. Similar drawing for the last Congress. Even more packets read. This is number of packets read per minute during the entire day. As you can see, as conference ended slightly earlier, there is no data to compare here, and we have very fast drop when server was just switched off. So let's go to the interesting part, analysis of data. What can we do with that? If we have just the release data set, we can tell something about behavior, but not much. But if we get also the positions of the readers, either from the PDF or extracted from the source code of Leica, program used for visualizing, it will allow us to detect where someone were at the particular time. So this, I will show you a few of those scatter plots. They basically, here one red mark means that this station read a packet at this time. So it allows us to detect how where someone was, or at least which stations were able to detect. So for this particular person, this person was mostly in the cafeteria area for almost entire Congress. He or she did not come or did not buy tag till the ending of the second day. Left for the night, was in the cafeteria for a long time, not moving, because when you have the straight line without any missing points, it means that this station was able to detect this tag continuously. When you have some kind of either here the gap, or when you can see that other stations were able to detect it mostly means that this person was moving. So many stations were able to detect presence of this tag. So when we have here, someone was standing in the one place or sitting in one place. And those stations are in the cafeteria area. So someone was not attending many lectures, but mostly sitting and socializing. Here is someone who was in the Saal 1, which is the biggest lecture room in the BCC. As you can see, not many drops, maybe sometimes moving, but for most of the time, just sitting in one place. This could be someone responsible for a video team or audio team, or someone was just sitting there with laptops, because in the Saal 1 there was many power outlets and many network cables available, so maybe just someone was sitting in front of his or her computer. This is probably Angel, volunteer responsible for checking tickets. Why? Does anyone have idea? Yeah. First, F002. This was the station which was in the area only available to angels. So if there is continuous reading from this area, it probably means that this was angel. I'm not quite sure, because it could be some kind of mishap or something like that, but most probably this was the angel, or at least someone who entered this and was not kicked out of this room. And after that, he or she went and was near the entry and near the exit. So this was the person that was standing near the entrance or near the exit, so he or she was probably either checking tickets, getting cash for the tickets, or hanging the clothes and things like that. So this is one case. This person, this was also angel, and was sitting in the heaven for almost entire Congress, except for leaving for the night and getting back about 6 p.m. or something like that, except for part of the day, of the third day. So I was not in heaven, so I don't know what can be interesting there, but nonetheless. This was also angel, and was also not moving very much. So I went through the data set and calculated all probable angels, the IDs, the count, and the minimum time that this tag was seen by our beloved station F002, and maximum time. If like this there is where it was, if there is only few minutes and few packets read, it was probably just mistake. But the larger number of packets, the more probable that it is the angel. If you want the full list, it is in the article. And this is different situation. Here is someone who probably attended many lectures, because we have parts of times when we have when there is one person is sitting in one place, and once every hour there is some movements. So if we compare this to the schedule, we could see that those movements are present when there were breaks between the talks. Also, though this is the Saal 1, the biggest one, this I think is the Saal 2, and one of them is Saal 3. So this was person who who was, I think, not socializing much, or at least going to the many lectures and then sitting there. By checking for which positions there is, for which rooms those readers belong, we could even check in what lectures he or she was present. Okay, and now let's play. What can we say about this tag? Some ideas? Excuse me? Hack center, maybe. Yes, see. Yeah, quite probably, because some of the C readers were in the hack center. Something more? Leaving for the night, yeah? Not present during the first day. What here? Okay, here was the last lecture, which was summary of the Congress. So it was in Saal 8. We can also see, or at least assume, that this person knows German, because just before the summary, there was another talk in the same room, which was held in German language. Or at least, either we assume that he or she knows German, or that this person was just sitting there waiting for this lecture, for this last lecture, wanting to be sure that he or she has sitting place, because as it was the last lecture, there were problems with sitting places. Okay, now let's skim through positions. Tags were sending signals, packets more than once a second. So during the short area, we were able to detect few dozens of packets. We know the positions of tags, of readers, and we know strength of sent signal. So we could try to calculate positions. This is my attempt of calculating the position. So we just take a position of reader, calculate it by weight, which is based basically on the strength of the signal. There was 4 different strengths of the signal, 0, 1, 2, 3, in increasing power level. So we just calculate weighted sum of the positions of readers and divide it by sum, so we get basically some place in the middle between readers that were able to detect this tag. I'm not sure which one of those equations is the most correct. They all give similar results because on the range of of about 10 meters or something like that, there is no much room for wiggling, so we do not know how to check it. It would be interesting to see how well it would behave on such a camp or something like that, but we do not have any possibility of doing it now. Unfortunately, we have problems because those equations do not take into consideration any physics, so it may mean that there are some very fast movements which could look like teleportation. Basically, it looks like this. This is not very good because this is just a noise. We have rough position, but this position is not very precise. I could be standing there, and I could be standing few meters away, and this would not matter, because I could be just the calculated position would be just as noisy as in both cases. I tried to play a little bit with time settings and strength and all of those were, in all cases, I was getting the similar results. Okay, this is, I believe if I remember, this is the person who attended many lectures. So you already seen data from this person. As you can see, there are more or less constant positions, but they are not very good ones. I even tried to kind of use fast Fourier transform to kind of make this data more smooth, but it was not very precise then. So there is, I'm afraid there is no good solution. So during the last hope, they have two different floors, which were which were far away, and it means that they have more easy situation. But I do not want to talk too much about the position. So now, for something completely different, the HAR or the task for you. What can be said about this sequence? Some ideas? Excuse me? Okay, not to hold you too much. This person was staying mostly in the same place, in these green areas, and for 1 hour or so in these blue readers, in the range of these blue readers, and during the last talk, he or she, or I could see, he was in the Dessal eyes. So he was attending the last lecture. This is summary what I said. It was near the Sputnik station, Sputnik table. During that day, when blue stations were active, there was presentation of the Sputnik data. I believe it was the Miloš Mariak, the creator of the Sputnik project. When I asked him, he neither confirmed nor denied that it was him, but he said I could use this as the example. By the way, as I said, D002 was just below the Sputnik tables, and it was in the different level, and it was also able to detect this. So this is Miloš. So summary of positions. We do not always need the exact positions, but having a rough idea where someone is helps. But for the Sputnik system, we do not need this. Okay, I'm afraid I'm getting out of time, so I will just talk about entropy, which I believe is very interesting. Entropy is the measure of how much data is random or how much it is unpredictable. It was proposed by Shannon. It is calculated like that, so we have probability of getting value, some of those probabilities multiplied by their logarithms. Minus comes because probabilities are in range of 0 to 1, so if we get logarithms from this, we would get negative values, so we want to have positive entropy. I used rather sophisticated query to calculate this entropy. I got a short period of time, divided it into few seconds sub-periods, get all stations that were seen, calculate maximal strength of the signals from those sub-periods, calculate how many different combinations of those are in the system, then treated a number of those combinations as base, divided each number by this base, and got the entropy. So here are examples of some. This is entropy, global entropy of all subjects. Low entropy means basically someone was not moving much. High entropy means that someone was moving very rapidly and very much during the contest. So here are the entropies of people that I already talked to you about. So this was Angel responsible for tickets. When he was in heaven, we have low entropy, which means that he was in one place and not moving very much. Oh, by the way, entropy almost never goes to zero. If it goes to zero for long periods of time, it probably means that someone just left the tag sitting and was not wearing it. Because of the tags, of the way I'm calculating entropy, there is problem with, there is almost impossible for living person to have zero entropy when he or she is wearing tag. This is angel sitting in heaven. As you can see, he or she was there in the one place, except for the one day I was talking to you about, when it is very large entropy. Here is someone who attended many lectures. As you can see, during the most time it was low entropy, sitting in one place, except when it went to high entropy, when he or she was going to the another room or to get some food or things like that. Because, as you can see, or as you probably wonder why, during the last day there was slightly larger entropy than during the previous days. Because we do not have any social data about the subjects, because we do not know who it was, whether it was man or woman, what he or she was finding interesting, we do not know what caused this behavior. Maybe it was just that his or her friends came on the last day and they were just more socializing and less going to the lectures. So, okay, I think I will leave the AMD. AMD was just intended to get the social data from people, so people were able to log into the web page and give their nicks and handles and things like that, and then it was able to people were able to see not their numbers but their nicks on the. Okay, one more slide. AMD just screwed up in one place. They intended to anonymize this data, and they almost succeeded, except in that they have not very normalized tables, and in one table they left all the nicks. They replaced all the nicks with user NNN, but in one table they left it. So those are few sample names. Okay, I think I'm done. Are there any questions? For the question, please go to the microphone or ask for the herald to,
and we'll come to you.
To get this.
While we're doing the questions, can you run some of the visualization movies?
Excuse me?
Can you run some visualizations while we're doing the questions? Some of the movies? You said there were visualization movies?
Visualization movies. I do not have them with me. I can... wait. I might find it, but I'm afraid it would take too much time. If someone wants, I have one sample flash video of visualization of positions of tags.
Will you be around after this talk, perhaps?
Yeah, I will be around. Oh, by the way, my number for the DEX phone is 3999. So if you are interested in talking or something like that, you can call me. There is one more.
Have you ever thought of using those tags as that kind of moving radars? You could, if you could have more accuracy in the signal, you could perhaps use the signals of those tags to as a quite something like radar technology. You could track people.
I'm not sure if I understood you fully. You mean that we could use the tags as the radars? In what way? Because radar sends the signal and then measures how it was reflected from the object, like the plane, the ship, or something like that. In tags are sending signals and readers are receiving them.
Yeah, but if you know the position and then you have the arrow there, you could from the arrow you could interfere.
No, it could be you mean for calculating positions?
Yeah, but there's the arrow, and then I guess. Thanks. If you have the arrow, if you can calculate the position, and then there's someone between with laptop or something like that interferes the signal, you could interfere that, okay, there's someone between the tag and the reader or something like that. You could use them as moving radars.
Maybe not as radar, but as detecting whether someone is and correcting this data. If we know position of the other person, you mean? It could be possible, but those errors that you saw were in the range of 2 meters across. So the problem with the Sputnik system is that they are active in the 2.4 gigahertz range, and it is this kind of electromagnetic radiation is very sensitive to the water, and we humans are made of water. So when I was showing these tags for the students, and one just moved away slightly, it took only 3 persons standing roughly between the reader and the tag to all the readings disappeared completely. So
that's how you can if it reacts to water, you can detect that someone between the tag and the reader.
yeah, but I'm not sure we have enough computing power. It could be done offline, I hope.
You've shown us that it is impossible for a person to have zero entropy in the signal. Is it possible to...
It is almost impossible.
Almost impossible. Is it possible to make a fingerprint of a person the way he moves? Is the signal...
In the way they move.
Is the resolution enough?
You mean whether someone, like some kind of gates, or whether someone moves more slowly or fast or something like that? I'm not sure only entropy will be enough for that. But maybe entropy and trying to calculate the path positions or something like that, I think it could be possible, but it would definitely not be so easy. And I'm not sure how sure you would be that this is the correct person.
Well, maybe
it would require some kind of... it would require much research, and I think it could be even good topic for the thesis or something like that.
Maybe the breathing rhythm of a person. Maybe the breathing rhythm of a person.
This is not. The tags are not sensitive enough to detect breathing.
Okay, that's what I wanted to know.
Oh, okay.
I think we might have to wrap up. Is there anything else you want to say before I do? Can I do anything? If you could do a big round of applause, please, for Tomas.
Thank you very much.
Fantastic talk on really very relevant to randomness, hacking at random. I've got a couple of announcements. The first is, as I mentioned at the start of the talk, the iPhone talk in this hall at 7 tonight has been cancelled. Other announcements, at 11 p.m. tonight, there will be another WikiLeaks panel talk in this hall. So if you were excited and thrilled by what you heard last night at 11, be back tonight for more. If you've not yet heard, at 4 o'clock, 2 talks have been moved to another room. The relaunch Bits of Freedom is now in the 2 Envelopes tent. So that's a new venue, the 2 Envelopes tent for the, 4 o'clock relaunch Bits of Freedom. And also at 4 o'clock, the Tempest for the Casual Election Hacker has been moved to Monty Hall. So that's the 4 o'clock Tempest for the Casual Election Hacker has been moved to Monty Hall. Thank you.